everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation with variable equations. So let's get going. Problem: solve x squared d squared plus 2xd minus 12 into y equals to x cubed log x. So we are given a differential equation with variable coefficients. We are going to reduce this to an equation with constant coefficients by making a substitution. Okay, let's given differential equation x squared d squared plus 2xd minus 12 into y equal to x cube log x, which is a Cauchy's equation. So we are given a Cauchy's equation. Now we are going to make a substitution. Put x equals to e power z, then log x to the base e equals to z. For x greater than 0, let theta equals to d by dz, where theta is a differential operator with z as an independent variable. The next t equals to theta, x squared d squared equals to theta into theta minus 1. Now the above equation becomes theta into theta minus 1 plus 2 theta minus 12 into y equal to, replace, you can just write directly replace log x by z. This becomes theta square minus theta plus 2 theta minus 12 into y equal to e power 3z into z. Then this equation becomes theta square plus 2 theta minus theta is plus theta minus 12 into y equal to z e power 3z, which is in operator form. See, we have constant coefficients. So we have reduced the given differential equation with variable coefficients to a differential equation with constant coefficients, and also this is of operator form, which is in operator form. F of theta into y equal to q of z, where f of theta equals to theta square plus theta minus 12. Now we need to find the general solution to the given equation, which is given by y equal to yc plus yp. Let's now find yc and yp. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of theta square plus theta minus 12. Let's replace differential operator theta by m, so that we'll get f of m equals to m square plus m minus 12. Then our auxiliary equation becomes m square plus m minus 12 equal to 0. Write plus m as plus 4m minus 3m minus 12 equal to 0. Plus 4 minus 3m is plus 4m minus 3m is m, plus 4 minus 3 plus 4 into minus 3 is minus 12, right? Now take m common from the first two terms, we'll get m times m plus 4, and take minus 3 common from the next two terms, we'll get minus 3 times m plus 4 equal to 0. If you notice, we are having m plus 4 in both the terms, so let's take m plus 4 common from these two terms, we'll get m plus 4 into m minus 3 equal to 0. Now equate each factor to 0, we'll get m equals to minus 4 and m equals to 3, right? Then m equals to minus 4 plus 3 are the roots of our auxiliary equation. So here the roots are real and distinct. Therefore, the roots are real and distinct. We know that when two roots are real and distinct, say m1 and m2 are real and distinct, then yc will be c1 e power 1 root into z plus c2 e power another root into z. Then our complementary function will be yc equal to c1 e power minus 4 into z plus c2 e power another root into z, which is equals to c1 e power minus 4z plus c2 e power 3z. Right? Now we are having roots, yc in terms of z. We need to write in terms of x. For that purpose, we'll write e power minus 4z as e power z whole power minus 4 plus c2 into, write e power 3z as e power z whole cube. Now replace e power z by x. Then we'll get yc equal to c1 x power minus 4 plus c2 x cube, or we know that x power minus n is 1 by x power n, then we can write x power minus 4 as 1 by x power 4. Okay, second term remains the same. This equals to c1 by x power 4 plus c2 x cube. So therefore yc equal to c1 x power minus 4 plus c2 x cube, or c1 by x power 4 plus c2 x cube. We got yc. Let's now find yp. We can find yp using 1 by f of theta into q of z. We have f of theta, theta square plus theta minus 12, and q of z is z into e power z. Right? Also we have roots. We got roots, right? M equals to minus 4 and 3. So we can write theta square plus theta minus 12 as theta plus 4 into theta minus 3. Right? Or because theta square plus theta minus 12 is theta plus 4 into theta minus 3. Okay? So for our convenience, because here I'm having e power 3z, so I'm going to write f of theta as theta plus 4 into theta minus 3. And see, this of 1 by f of theta into e power az into z form, right? Not z, just a function of z, say v. Now we'll shift e power az towards left by replacing theta with theta plus a, and later we'll operate v with 1 by f of theta plus a. So yp becomes 1. Shift e power 3z towards left by replacing theta with theta plus 3. Okay, just compare this with 1 by f of theta into e power az into v. Compare e power 3z with e power az, then for a equals to 3, we'll find theta plus a, which is equals to theta plus 3, right? So now replace theta with theta plus 3. We'll get theta plus 3 plus 4 into, replace theta with theta plus 3, we'll get theta plus 3 minus 3 into z. Then yp becomes e power 3z into 1 by theta plus 3 plus 4 7 into 3 plus 3 minus 3 gets cancelled and you'll get theta into z. So we can solve yp in two ways. We can split the fraction as 1 by theta plus 7 into 1 by theta into z. Okay. So you can just write it as e power 3z into 1 by theta into 1 by theta plus 7 into z, or e power 3z into 1 by theta plus 7 into 1 by theta into 7. Firstly, you can operate z with 1 by theta plus 7, or we can operate z with 1 by theta. Okay. Let's see both the cases. So I'll show you the first case. 1 by p equals to e power 3z into 1 by theta into 1 by theta plus 7 into z. This is equals to e power 3z into 1 by theta into, see this is of 1 by some function of theta into z power k form. Right? Now, take the lowest degree term common from these two terms. Since theta has no 7, so we'll multiply and divide 7 to the first term, theta. Okay, this is equals to e power 3z into 1 by theta into, now take 7 common from the two terms of denominator, will get 7 into theta by 7 plus 1 into z. This is equals to e power 3z into 1 by theta into 1 by z, 7 into 1 by, you can just write as it is, theta plus 7 plus 1 into z, right? Which is equals to e power 3z into 1 by 7 is 3 e power 3z by 7 into 1 by theta into, we can write this fraction as 1 by 1 plus theta by 7 into z, right? This is equals to e power 3z by 7 into 1 by theta into, we can write 1 by 1 plus theta by 7 as 1 plus theta by 7 whole inverse into z. Since this is of 1 by 1 plus x form, we can write it as 1 plus x whole inverse, right? Now we can expand this using 1 plus x whole inverse formula, which is equals to 1 minus x plus x square minus x cube plus so on. So before applying this formula, we'll find derivatives of z. Theta of z is 1, right? Theta of z in the sense d by dz of z. Derivative of z with respect to z is 1. Likewise, find theta square of z, which is equals to theta of z. We have the value for theta of z, which is a constant. Then derivative of a constant with respect to x is 0. So we'll get theta square of z equals to 0. Likewise, theta cube of z equals to 0, and so on. In general, theta power k of z equals to 0 for k equal to 2, 3, 4 and so on, right, from here. So we can neglect higher derivative terms from here. Okay, let's see. Let's expand 1 plus theta by 7 whole inverse, which is equals to 1 minus theta by 7 plus theta by 7 whole square minus theta by 7 whole cube plus so on. This is equals to 1 minus theta by 7 plus theta square by 14 minus theta cube by 7 cube plus so on, right? So here we know that the values of z for theta square, theta cube and so on are zeros, right? So we can neglect higher derivative terms completely from here. Then only first two terms we can use. So here, coming to yp, expansion of 1 plus theta by 7 whole inverse is 1 minus theta by 7 plus theta by 7 whole square minus theta by 7 whole cube plus so on into z. This becomes e power 3z by 7 into 1 by theta into 1 minus theta by 7 plus theta square by 7 square minus theta cube by 7 cube plus so on into z. Since we know that theta power k of z equal to 0 for k equal to 2, 3 and so on. So neglect higher derivatives from theta square, theta cube and so on. Okay, so we'll neglect all the terms from here. Then yp becomes e power 3z by 7 into 1 by theta into 1 minus 1 by 7 into theta into z. Then yp becomes e power 3z by 7 into 1 by theta into 1 into z is z minus 1 by 7 into theta of z. This is equals to e power 3z by 7 into 1 by theta into z minus 1 by 7 into theta of z value is 1, which is equals to e power 3z by 7 into 1 by theta into z minus 1 by 7. This becomes e power 3z by 7 into, we know that 1 by theta is an integral operator, then find integral z and minus 1 by 7 dz, right? Okay, we'll see. We'll just write 1 by theta as integral of z minus 1 by 7 into dz, okay, which is equals to e power 3z by 7 into integral z dz minus 1 by 7 dz is equals to e power 3z by 7 into integral z dz minus 1 by 7 into integral dz. This becomes e power 3z by 7 into integral z dz is z square by 2 minus 1 by 7 into integral dz is z, right? Now take the LCM of 2 and 7. 2 sevens are 14. So 14 is our LCM. In the numerator we'll get 7. Just in the denominator first term we are having 2, so close to, and multiply this 7 to the numerator, we'll get 7z square minus, in the denominator of second term we are having 7, so close 7, and multiply this 2 to the numerator, 2z. Okay. Yp becomes e power 3z by 7 into, now split this fraction as 1 by 14 into 7z square minus 2z is equals to e power 3z by 14 sevens are 7 4s are 28, 7 1s are 7, 7 plus 2 9. E power 3z by 98 into 7z square minus 2z. Now let's write this in terms of x. For that purpose, I'll write e power 3z as e power z whole cube by 98 into 7z square minus 2z. Now replace e power z by x and z by log x to the base e or log x. Then yp becomes x cube by 98 into 7 log x whole square minus 2 log x. Okay, we'll get this answer by operating z with 1 by theta plus 7 firstly. Okay, now let's see the second one. We know that 1 by theta is an integral operator. Then find integral z. Is equals to e power 3z into 1 by theta plus 7 into z squared by 2. Again split z squared by 2 as 1 by 2 into z square. Now take this constant towards left. We'll get e power 3z by 2 into 1 by theta plus 7 into z square. Right? So this is of 1 by some function of theta into z power k form. 1 by some function of theta into z power k form. Now take the lowest degree term common from these two terms. This becomes e power 3z by 2 into 1 by, we don't have 7 in the first term, so we'll multiply and divide 7 to theta. And now we'll take 7 common from these two terms. We'll get e power 3z by 2 into 1 by 7 times theta by 7 plus 1 into z square. Right? This is equals to e power 3z by 2 into 1 by 7 into, we can write theta by 7 plus 1 as 1 plus theta by 7. Now split this fraction. We'll get 1 by 7 into 1 by 1 plus theta by 7 into z square. This becomes e power 3z by 2 7s are 14 into, we can write 1 by 1 plus theta by 7 as 1 plus theta by 7 whole inverse. Since this is of 1 by 1 plus x form, so we can write it as 1 plus x whole inverse into z square. Now we need to expand this using 1 plus x whole inverse formula. Binomial series expansion, 1 minus x plus x square minus x cube plus so on. So before applying this formula, we'll find derivatives of theta square. Derivatives of z square. Derivative of z square is 2z. Theta square of z square is 2, right? We can write theta square of z square as theta of z square, which is equals to theta of z square value is 2z. Here theta is a differential operator. Right? Now we'll get 2 into theta of z, which is equals to 2 into 1 equal to 2. Likewise find theta cube of z square. Theta cube of z square is theta square of z square. We have the value of theta square of z square, which is a constant. Then theta of 2 will be 0, right? Theta cube of z square is 0, since derivative of a constant with respect to z is 0. Likewise, theta power 4 of z square is 0 and so on. In general, theta power k of z square is 0 for k equal to 3, 4 and so on. Right? Now keeping this in mind, we'll expand 1 plus theta by 7 whole inverse. Is equals to 1 minus theta by 7 plus theta by 7 whole square minus theta by 7 whole cube plus so on. This is equals to 1 minus theta by 7 plus theta square by 7 square minus theta cube by 7 cube plus so on. We know that all the derivatives of z square from theta cube is 0, right? So we'll neglect all the terms from here. So we'll get only the first 3 terms. Now coming to YP, write the expansion here. 1 minus theta by 7 plus theta by 7 whole square minus theta by 7 whole cube plus so on into z square. Then this becomes e power 3z by 14 into 1 minus theta by 7 plus theta square by 7 square minus theta cube by 7 cube plus so on into z square. Since theta power k of z square is 0 for k equal to 3, 4 and so on, so neglect higher derivatives from theta cube, theta power 4 and so on. So we are going to neglect all the terms from here. Then we'll get yp equals to e power 3z by 14 into 1 minus theta by 7 plus theta square by 7 square is 49 into z square. Then yp becomes e power 3z by 14 into 1 into z square minus 1 by 7 into theta of z square plus 1 by 49 into theta square of z square is equals to e power 3z by 14 into z square minus 1 by 7 into theta of z square is 2z plus 1 by 49 into theta square of z square is 2. yp becomes e power 3z by 14 into z square minus 2z by 7 plus 2 by 49. Now we can split this as e power 3z by 14 into z square minus 2z by 7 plus e power 3z by 14 into 2 by 49. 2 ones are 2 sevens are. Now this becomes e power 3z by 14 into 7z square minus 2z by 14. Sorry, you'll get 7, right? This is equals to e power 3z by 14 into 7 into 7z square minus 2z. E power 3z by 7 49s or 49 7. 7 9s are 63. 7 4s are 28. 28 plus 6 is 34. Right? Then this becomes e power 3z by 7 49s 343. Which is equals to e power 3z by 14 sevens are 98 into 7z square minus 2z plus e power 3z by 343. See, we got yp in terms of z, right? Let's write it in terms of x. For that purpose, we'll write e power 3z as e power z whole cube by 98 into 7z square minus 2z plus write e power 3z as e power z whole cube by 343. Now replace e power z by x and z by log x. Then yp becomes x cubed by 98 into 7 log x whole square minus 2 log x plus x cubed by 343. Just observe these two. If we go for the first term, in the first way, we'll get this answer. If we pick the second one, we'll get one extra term. Okay. Later, we can include this in constant C2x cube. Okay. So we have two yp's. If we pick the first one, we'll get yp equal to x cubed by 98 into 7 log x whole square minus 2 log x. If we pick the second one, we'll get yp equal to x cubed by 98 into 7 of log x whole square minus 2 log x plus x cubed by 343. So we got yc and yp. Let's write the general solution. The general solution is given by y equal to yc plus yp. Okay, I'll pick the first yc. Okay, then I'll get y equal to c1x power minus 4 plus c2x cube plus, for the first yp, x cube by 98 into 7 of log x whole square minus 2 log x, or y equal to c1x power minus 4 plus c2x cube plus, go for the second yp, x cube by 98 into 7 of log x whole square minus 2 log x plus x cube by 343. Right? Again, if you pick the second one, you'll get two more general solutions. You can get any of the four solutions. Okay, I'll write the remaining two also. So if you pick the second yc, then you'll get these solutions. Okay, so you may get any of these four. So the solution always depends on the method you choose. Fine. So we have seen a problem from higher order linear differential equations with variable questions in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.